So, I mean, the purpose of this is to try to open up for either more general questions or if you have questions directed to any of the individual speakers. Otherwise, I have questions. So, and Gabriel has a microphone. Are there any questions that you have thought about? No questions. Oh yeah, Harold. Yes, please.
Given the way this society is developed, we attack more and more complex problems, and they result in some type of system that is evolved in computing. At what time, and nobody has addressed this, at what time do we teach people how to cooperate in cooperative problem solving that would lead to good software engineering and good solutions to problems?
If I can take it from the computer science perspective, that's one of the things that I've worked with the last 18 years in Uppsala. We're particularly interested in putting students, in fact, into international collaborative environments where they work both with virtual tools and physical equipment. So the video that I showed you there, a short snippet of, those students were actually working with students in Vietnam also. Through a collaborative online system. They'd spent 12 weeks trying to develop and debug the system that they were trying to demonstrate, with all of the challenges, both cultural, communication and technical, that involves. The result, I think, they found rather disappointing. Half the time the robot didn't move and their algorithms didn't really work. But what they had experienced was worth much more than the value of the artifact itself, which was the message I was trying to point across. So I think that we are doing it. I think we should do it much more. But it's something also that we have started to recognize and there's a literature around this in the international computing and systems development communities about this.
Is it something we should have at the high school level or the university level, or where should we start to introduce this? Even a preschool.
Preschool.
Well, you said they should learn to communicate, and that's probably an important aspect, and work with other fellow students.
Okay, thank you. More questions? So actually, I wanted to follow up on that. I mean, because I mean, there is this saying that you should fail fast and learn quickly. And I mean that some people argue that school is not an environment which encourages failure, rather it's doing the opposite. So what's your view on that? Should we try to get failure to be a more important part of the educational system? And in that case, how should we do that? Oh, so you're first, yeah?
Yes, I went to a study visit in London to look at how they are using computing in their classrooms, because they have that for a few years, and since we're going to introduce it in Sweden, and they were actually highlighting the mistakes, and after a programming or coding lesson, the teacher would ask, "Okay, anyone who made a mistake, hands up," and the kids were, "Yeah," and then they talked about the mistakes, but also how they thought they could have a solution for that mistake. And then there was an applause, actually. Yay! Which I think actually seemed to work. And I hope we can get that in Sweden as well.
I mean, this is, again, it's nothing new. This is what we should teach our students, regardless of whether we talk about technology or not. And I think that the question actually points out that education to some point is going in the wrong direction of focusing too much on the correct answer, the correct ways of doing anything. I mean, we can go back to Vygotsky, we can go to the newer uses of Vygotskian pedagogy, and it is what you said as well, make them fail or make them try and then realize that it's okay to fail. So definitely, if learning or teaching them computational skills is a new arena for actually teaching that it's okay to fail, I welcome it hugely.
Yeah, Matti. Yeah.
Yeah, in the field of ICT for development, which is notorious for failures of all kinds, Lately, even conferences have started to celebrate failure. There has been in major conferences. There have been in major conferences. There have been so-called fail fairs, where people go and tell how they failed so big, and those are fantastic situations for everybody.
So maybe computing will be an arena for introducing failure into school and learning from it.
Can I follow up on that one, though,
Yes,
Fredrik?
yes.
I think one of the things that contributes to this culture is that we test too much. And this is one of the trends that's been very prevalent also in Australia, that we over-test. And we focus too much on students performing on individual examinations. National tests are possibly, I hate to say it to anybody from school advocates who's here, but I think national tests are one of the most destructive exercises we can engage in, actually. But that's my personal opinion.
Seem to be some consensus, or at least other people agreeing on that. So I wanted to ask one final question before lunch here, and that's, I mean, we've heard a little bit, I mean, we started out kind of with computational thinking, and maybe in the last two talks it was more about digital competence. But from your perspective, what would you say is the most important for primary and secondary education? Which would you point as the more important, if any?
So this is the kind of answer where I'm not going to answer that, because I think that we need to realize that this is an arena where, or field, where we don't know the most. So I would say that we need to encourage students to tell us what they know and what they can do, and then to use, again, the personal relevance for the students. So instead of deciding on what to teach at what point, drawing on their competences into the classroom and then again discussing how it can be used. I think there are a number of answers to what can be taught. You can choose one and it's going to work if you're interested as a teacher and the students get a chance to try and to show what they already know.
But doesn't that put extremely a lot of pressure in some sense on the teacher? That
Well,
the teacher need to, on an individual kind of basis or classroom basis, be able to take in what their needs are and then provide sufficient guidance from there.
The opposite, I would say.
Okay.
It's easier for the teacher if it's again, we've talked about failure, we talked about not necessarily knowing everything. So instead of the teacher knowing or believing that now I've read up on something or I'm really good at something, you share that responsibility with the students. It's more authentic anyway, I think.
Other comments?
I think it's important that we shouldn't give the impression that we're infallible to follow up on that. In my introductory programming classes some years ago, I just took the laptop into the class and I said, okay, so what sort of code would we like to write today? And somebody up the back would yell out, oh, write something that demonstrates X and Y and Z. So I would start to write some code and then we would have a discussion about that. And I'd say, okay, so what should I write next? And there would be some suggestions and people in the classroom would start to talk amongst themselves. No, I don't think you should tell him to write that because I think this, and this is authentic learning, right? Yep. And then they could see me make mistakes and see my mechanisms for recovering from them, which is something that we don't do very much in computing or mathematics. We present the outcome. We don't present the process. So I think a lot of students actually thought that I could write, because I was a professor, I could write an absolutely correct compiling program, just bang, straight down to the machine, right? It doesn't work that way. Yeah, exactly, everybody laughs. But you go and talk to a first year student, I bet that they have a good fraction of that conception, that I'm stupid and the professor knows.
Yeah, Matti, please.
Yeah, I'm just happy that it's not a binary choice and they don't exclude each other at the same time too. So.
Okay, thank you very much. So let's thank our speakers again.